The first question says, write 70 as a product of its prime factors. So 70 can be split into 7 times 10. 7 is a prime number, so it stays as it is. 10 can be split into 5 and 2. Since all these three are prime numbers, so it's going to be 2 times 5 times 7. We cannot further break these down. Then it says, find the highest common factor of 70 and 112. So let's break down 112. 112 is basically 56 times 2. 56 is 28 times 2. 28 is 14 times 2. And 14 is 7 times 2. So we have 1, 2, 3, 4. 2 to the power 4 times 7 is 112. And 70 was 2 times 5 times 7. So highest common factor over here is 2. So highest common factor over here is 1, 2, and the 7. So that's going to be 14 because 2 times 7 is 14. The next part says, find the lowest common multiple of 70x to the power 4 y square and 112x cubed y to the power of 5. So we know that 70 was 2 times 5 times 7. So 70x to the power of 4 y squared is going to be 2 times 5 times 7 times x to the power of 4 and y squared. For 112, it was 2 to the power of 4 times 7. So 112 x cubed y to the power of 5 is going to be 2 to the power of 4 times 7 times x cubed times y to the power of 5. So now for the lowest common multiple, we can see that it's going to be 2 to the power of 4 times 5 times 7 times x to the power of 4 times y to the power of 5. So this all multiplies to 560 x to the power of 4 y to the power of 5. The difference between highest common factor and lowest common multiple is that for highest common factor, we look at the highest number that's common. And for the lowest common multiple, what we do is we pick the bigger factors, the big factors in each case, and then we multiply those. So over here, when we're talking about the 2's, 2 to the power 4 was bigger. So that's why we chose that one. There was only one 5, so we picked that 5. The power of 7 is the same, so we picked that 7. Then for x, x to the power 4 was bigger. For the y, y to the power 5 is bigger. So we pick these, and then we multiply those, so that gives us the lowest common multiple. Whereas for the highest common factor, we see which number occurs, like in both the things. So the highest common factor we notice to be 2, because 2 is common between them. And for that, we pick the lowest power. So for the multiple, we pick the highest power, and for the factor, we pick the lowest common power. And the other was 7, so 2 and 7. So if you write this down, lowest common multiple, pick the highest power. And for highest common factor, pick the common power. Then it says simplify a to the power of 12 divided by a to the power of 4. So when you're dividing similar bases, we will subtract the powers. So 12 minus 4, and that is going to be 8. Then over here, we are dividing and multiplying at the same time. So when we're multiplying fractions, what we can do is we can simplify vertically or diagonally. So if we do it vertically for the first one, it's not possible because 5 and 2 and B don't come in the same times table, except for the 1 times table. And for B, C, 20, I can't simplify as well because all three don't come in the same times table. So let's see if we can do it diagonally. So diagonally, 5 and 20 come in the same times table, which is the 5 times table. So 5 ones are 5 and 5 fours are 20. Diagonally, B and B can be cancelled out because they both have the same degree of power. So we're left with C over 2 times 4, which is C over 8. So that's your simplified answer. Then it says solve 4 plus 2x equals to 15. So this is an example for a multi-step linear equation where we need to isolate x and make it the subject to find its value. So first step is to move 4 to the other side. So when you move 4 to the other side, it becomes minus 4. Remember, when you're moving terms from one side to the other side, whatever function is performing initially, on the other side, it does the opposite thing. So if it's being added, it gets subtracted. If it's being multiplied, it gets divided on the other side. So 2x equals to 11 and x equals to 11 over 2. Since 2 was being multiplied to x over here, on the other side, it's dividing. So you can write it as a fraction or a decimal. Then solve 34 plus 2x over 5 equals to 4 minus x. So, okay, so whenever we have like a fraction on one side of the equal to, and like a fraction on the other side, or just like, a non-fraction expression, we need to first try to get rid of the fraction. So to get rid of the fraction, we can either cross multiply, or you can say that you're multiplying the entire equation by 5. So if we cross multiply, we get 34 plus 2x equals to 5 times 4 minus x. So we're going to multiply 5 with 4 and negative x. So that is going to give us 20 minus 5x. Now, once we've expanded the bracket and gotten rid of the fraction, what we can do is we can collect the like terms on each side. So to collect the like terms, I'm going to bring the variable on one side and the constant on the other side, which means 5x over here, 34 over here. So that's 5x plus 2x equals to 20 minus 34. 5x plus 2x is 7x. 20 minus 34 is negative 14. So x is going to be negative 14 divided by 7, which gives us negative 2. So that is your value of x. And part E says P equals to D plus cube root of M square. Find P when D equals to 7 and M equals to negative 8. So you just substitute the values. 7 plus cube root of negative 8 squared. Now, negative 8 squared is 64. When you square a negative integer, the answer is positive. Now, 64 is a cube number. 4 cube equals to 64. So cube root of 64 equals to 4, and 7 plus 4 is 11. That's your answer. Then it says rearrange the formula to make M the subject. So the equation is P equals to D plus cube root of M square. So to make M the subject, first I'm going to take D to the other side. So P minus D equals to cube root of M square. Now I'm going to get rid of the cube root. So for that, I will cube both sides. So it's now P minus D whole cube equals to M squared. Now to get rid of the square, we're going to square root both sides. So when we square root both sides, we get plus minus over here because square root of a value gives a positive and a negative value. And this is M. So M equals to plus minus square root of P minus D whole cube. For question 2, it says, on the grid, draw the image of triangle A after reflection the line x equals to 1. So x equals to 1 is basically this line. And if we reflect the shape in this, it's going to be 1, 2, 3, 4. This is a reflection. Why is this a reflection? Because the image, like the original image, the triangle A, lies exactly on the line of reflection. These 2 points are going to be exactly the same. They're not changing. What's changing is this point, 5, -3. So 5, -3 now becomes -3 and -3. The image of triangle A after an enlargement by the scale factor of 1/2 with center 5, 1. Center 5, 1. And scale factor is 1/2. So if this point is 1, 2, 3, 4 horizontally, 2 vertically, it's going to be 2 horizontally and 1 vertically. So this point is going to come over here. Let me color code this. This point is now this point. Initially, the distance was 4 horizontally and 2 vertically. So since it's half, the scale factor, so it's going to be 2 horizontally, 1 vertically. Now for this point, it's going to be over here because the distance is 2 units over here, so half of it is 1. And for this point, that's 1, 2, 3, 4 vertically. So now it's going to be 2 vertically. So if we join the points, this is your enlargement by the scale factor of half with center 5, 1. And since the scale factor is positive, that's why the image is like, the enlarged image is on the same side as the original image. Then says describe fully the single transformation that maps triangle A onto triangle B. So for triangle A onto triangle B, we can see that this is a 90-degree rotation and it's a clockwise rotation because we're going in this direction. For the center of rotation, what you can do is that you can first highlight the corresponding points on both shapes, connect those 2 points with a straight line, and then what you do is using your compass, you can create perpendicular bisectors, or using your protractor, you can just draw a 90-degree line. And then you can repeat the same steps for 2 other corresponding points like these 2 and these 2. And then those perpendicular lines are going to pass through the same point. They're all going to intersect at the same time, like the perpendicular lines for all 3 points. So the point through which they're intersecting, like passing through, that will be your center of rotation. And for this case, the center of rotation is going to be 2, 4. So that is how you find your center of rotation. So 90 degrees clockwise rotation about the center 2, 4. Then says the point AB is reflected in the line y equals to k. where k is an integer and b is less than k. Write the coordinates of the image of point AB in terms of A, B, and K. So if AB is reflected in the line y equals to k, k is an integer, and b is less than k. So if b is less than k, so if let's say it's y equals to 3, b is said to be less than k. So if let's say b is this, let's say this is AB. So when you reflect this point, it's going to come over here. So our A value is not changing. X is the same. B value is becoming twice of this minus 1. And this is our AB. So then this is going to be A twice of K, which is 2 times 3, let's say. That's 6, and then minus 1, that's 5. And this. Yeah, so in this case, what you have to do is like you have to assume a point and then start making your understand how the point would change once you reflect it. And then based on that, then you replace those points with A, B, and the final with A, because the x coordinate remains the same. For the y coordinate, based on the points I chose, your point is twice of the line, and then you're subtracting the value of B from it. So then you put it in terms of A and B and K, not just in terms of the points that you've chosen. It's a little tricky, but if we just assume, pick a point and then, reflect it based on the information given, and then just replace those with A and B, you'll get the right answer. Question 3 says the table shows the waiting times for 120 patients at a medical center. Calculate an estimate of the mean waiting time. So for the mean waiting time, the formula we use is sigma fx over sigma f. This is x, this is f. So over here, since we have intervals, we need to find the midpoint. So for midpoint, the midpoint of 0 and 10 is 5. 10 and 20, it's 15. For 20 and 40, it's 30. For 40 and 50, it's 45. For 50 and 80, it's going to be 65. So now we're going to multiply these values to the frequency values and add the result. So 2 times 5 plus 46 times 15 plus 33 times 30 plus 26 times 45 plus 13 times 65. This is divided by total frequency, which is 120. So when you solve this, what you should get is 30.875. That is your mean waiting time. So remember, when you have class intervals, you always find the midpoint of those intervals and use those as the x values, not the minimum points or the maximum points of the intervals. Part B says the histogram shows some information about the waiting times at a different medical center. Total number of patients is 90, and no patient waits for more than 80 minutes. Complete the histogram for the patients that have a waiting time between 10 and 30 minutes. So if the total number of patients is given as 90, you find the frequency for each of these given intervals. This is 1.1, 1.2, 1.3. This is 1.5. And this one is 0.4. So now frequency density has the formula of frequency over class width. So for each of these, we multiply the frequency density with the glass width to find the frequency. So for this one, it's going to be 1.3 times 10, which is 13. So that's the frequency over here. Then for this, it's going to be 1.5 times 20, which is going to be 30. For this one, it's going to be 0.4 times 30, which is going to be 12. 12, 30. So now if we add them up, total frequency is given as 90. So 90 equals to 30 plus 12 plus 13 plus x, which is the missing frequency over here. So that's going to be 30 plus 25, which is 55. So 90 minus 55 is x, and that is equal to 35. So now for 35, which is a frequency, width is 20. So frequency density for that is going to be 35 over 20, which gives us 1.75. So that will be the height of this bar. So 1.75 is going to be, this is 1.6, this is 1.7, so this is 1.75. This is your bar for this interval. Question 4 says Enzo, Rashid, and Blessy each swim as many lengths of a swimming pool as they can in 15 minutes. The results are shown in the table. Find the number of lengths Enzo swims as a percentage of the total number of lengths all three people swim. So 11.25 divided by the sum of 11.25, 18.75, and 20. And all of this multiplied by 100. That's going to give us 22.5%. Then the second part says write the ratio of the number of lengths each person swims in the form Enzo is to Rashid is to Blessy, giving your answer in its simplest form. So we have 11.25 is to 18.75 is to 20. So if we times all of these by 100, that's going to give us 1125, 1875, and then 2000. So now we know all of these are divisible by 5. So if we divide 1125 by 5, that gives us 225. 1875 divided by 5 is 375. And this one is 400. Again, divide by 5, 225. Divide by 5 is 45. Then 375 divided by 5 is 75. And this one is 80. So now lastly, divide by 5, it's going to be 9 and 15 and 16. We can't further break these down because 9, 15, and 16 don't come in the same times table. Then it says each length of the pool is 25 meters. Work out Blessy's average swimming speed for the 15 minutes, giving your answer in meters per second. So since we're asking for Blessy's average swimming speed for 15 minutes, and the length of each pool is 25 meters, an important thing about this is that if you go back to the table where they've shown us the number of lengths for each swimmer, Blessy's number of lengths is 20. So this is very important for this question because when we're writing the total distance. This is for each length of pole. So for 20 lengths, we're going to divide 20 times 25 by 15 times 60. Now, why 15 times 60? 1 minute is 60 seconds. So that means for 15 minutes, we do 15 times 60, which is 900 seconds. And for distance, we're doing 25 times 20 because once again, like they're saying each length of the pool is 25. And since Blessie's number of lengths are 20, so we do 20 times 25. So 20 times 25 is going to be 500 over 900, which is 5 over 9. And in decimals, that can be 0.556 meter per second. So that's your answer. Remember to highlight the keywords when you're solving the question, because in this question, you can easily miss out the each length part and just do 25 over 900 instead of doing 500 over 900. Then it says Rashid continues to swim at the same rate. Calculate the time it takes Rashid to swim a total distance of 5 kilometers, giving your answer in hours and minutes. Same rate, we found the rate was 5 over 9 over here. So with the same rate, and the length of each pool is 25, we need to look at the number of lengths. For Rashid's 18.75. So the rate that they're following is that 15 minutes, like that's the average rate at which he's finishing like his distance. So for every 15 minutes, he's covering a distance of 18.75 times 25. Each length is equal to 25 meters. How many lengths he's covering? 18.75. So we find the product of 18.75 and 25, and that gives us 468.75 meters. Now, this is the distance for every 15 minutes since they're using the same rate. Now, to see how many 15 minutes he takes in covering this 5 kilometers, so we will do 5,000 meters because 1 kilometer equals to 1,000 meters. So for 5 kilometers is going to be 5,000 meters divided by 468.75. I'm going to remove the meters. So this will tell us how many 15 minutes did he use to cover the entire distance. So 5,000 divided by 468.75, that's 10.67. Now to find the total time, we multiply 15 with 10.67 because we need to find how many minutes were there in total, because if he's using 15 minutes, 10.67 times, so the total time would be 10.67 times 15, which is basically 160.05, and we round that to 160, and this is in minutes because we're using 15 minutes. So now 1 hour equals to 60 minutes. So we know that 160 minus 120 is 40 minutes. So 120 is 2 hours. So 2 hours and 40 minutes. That is the time it takes Rashid to swim a total of 5 kilometers. Then it says Blessy swims for 1 hour. The number of lengths she swims decreases by 5% every 15 minutes. Calculate the number of lengths she swims in the final 15 minutes. So the number of lengths are decreasing by 5% every 15 minutes. First, we need to see how many lengths she swam initially, which is 20. So 20 lengths are decreasing by 5% every 15 minutes. Now, Blessy is swimming for 1 hour. And since they're decreasing by 5% every 15 minutes, that shows that this is exponential decay, like decrease. So for the exponential decrease, the formula we use is the initial amount or the principal amount times 1 minus r over 100 to the power of t, which is time. So r is 5 over here, and our initial number of lengths is 20. So 20 times 1 minus 5 over 100. Now for the value of t, we know that she's swimming for 1 hour. It's decreasing by 5% every 15 minutes. They want us to calculate the number of lengths she swims in the final 15 minutes. So that means we are talking about the first 15 minutes, second 15 minutes, and the third 15 minutes. Because once we've calculated the number of lengths after the third 15 minutes, then we know how much she'll be swimming in the last 15 minutes of that 1 hour. Hence, T will be 3. Once again, 1 hour has 60 minutes. So the 15 minutes are divided into 4 parts. 1 15-minute, 2 15-minute, 3 15-minute, and the fourth 15-minute. Okay. So this is the decrease in the first 15-minute, then the second 15-minute, and then for the third one, they're asking us how many she'll be swimming in this part over here, because how many she'll be swimming in the last 15 minutes. So we're going to decrease it 3 times, not 4 times. Hence, T is 3. So that's 20 times 0.95 to the power of 3. And that is going to give us 17.1475. So the number of lengths she's going to swim in the last 15 minutes can be rounded to 17.1. Then another swimmer, Adam, swims 450 meters correct to the nearest 25 meters. This takes 10 minutes correct to the nearest minute. Calculate the minimum distance Adam swims in 1 hour at this rate. So he swims 450 meters correct to the nearest 25 meters. So divide the degree of accuracy by 2. So 25 divided by 2, that's going to be 12.5 meters. So for the distance, we will subtract it. Why? Because they want the minimum distance. So 450 minus 12.5, which is going to give us 437.5 meters. Now for the time, it's saying that it takes 10 minutes correct to the nearest minute. So again, degree of accuracy is 1 divided by 2.5 minute. So for time, we'll find the upper bound. For distance, lower bound. For time, upper bound. So that's going to be 10 plus 0.5, which is 10.5 minutes. Now, the reason why we're finding the lower bound for distance and upper bound for the time is because they want us to find the rate, which is average speed in this case, or speed. So speed is basically distance over time. And since they want the minimum distance he is covering at this rate, that means the entire value, for the entire value to be minimum, like the lowest, our numerator is going to be lower bound and denominator is going to be upper bound. This gives us the minimum value. If we want the maximum value, then the numerator is upper bound and denominator is lower bound. So now for per minute, we're doing 437.5 divided by 10.5. This gives us the distance per minute, which is 41.6 recurring. Now to find the distance in 1 hour, because that is what they want, because same rate is being applied, hence we're going to use this value, and we're going to times this value by 60, because 1 hour has 60 minutes. So that gives us 2,500 meters as the minimum distance Adam swims in 1 hour at this rate. To summarize this, first we will use the degree of accuracy, divide that by 2 to get what we will be adding or subtracting to find the upper and lower bound. Since they're talking about the minimum distance that he swims in 1 hour at this rate, so for first to find the rate, which is the speed in this case, we divide the distance by time. And since we're dividing distance by time and we want the minimum distance, so we're going to find the lower bound of the distance, which is the numerator, and upper bound of the time. For the lower bound, we subtract, and for the upper bound, we add. The lower bound for the distance is 437.5, and upper bound for time is 10.5 minutes. So we find the rate for this per minute first. The per minute rate is 41.6 recurring. And then to find the rate for the entire hour, we multiply 41.6 by 60 because 1 hour has 60 minutes. And that gives us 2,500 meters. Question 5 says the box contains 3 blue pens and 5 red pens. Mia picks a pen from the box at random. Find the probability that she picks a red pen. So red pen would be 5 over 8 because there are 5 red pens and the total pens are 8. Then it says Mia puts the pen back into the box. She then picks a pen at random and replaces it. She then picks a second pen at random. Complete the tree diagram. So blue were 3 and red were 5. So 3 over 8, 5 over 8. And since she's replacing them back, so the probability is going to remain the same. The number of pens are not going to change. This is your tree diagram. If she was not replacing them, then your total number of pens would reduce by 1, and like the total number of red and blue pens would also reduce depending on which one you're picking. Find the probability that Mia picks 2 pens that have the same color. So same color is going to be either blue, blue, or it's going to be red, red. So now remember, when you're going along the lines, the branches of the tree diagram, you multiply. Across the branches, you add. So along the lines, we're going to do 3 over 8 times 3 over 8, then plus, because now we're going across it, 5 times 8 times 5 times 8. Plus 5 over 8 times 5 over 8. That's going to be 9 over 64 plus 25 over 64. Add them up, that is 34 over 64. And we can simplify that to 17 over 32. That's the probability. Then it says Mia now picks 3 of the 8 pens in the box at random without replacement. Find the probability that she picks 2 blue pens and 1 red pen. So she's picking 3 and the big 2 blue and 1 red. So if she picks blue, blue first and then red, or blue, red, blue, or blue, blue, red. Probability of blue was 3 over 8 and red was 5 over 8. So if she's picking blue first, 3 over 8, then picking blue the second time, now it's 2 over 7 because this is without replacement. So there's 1 less in the total and in blue. And red would be then 5 over 6. Then for the next possibility, if she's picking blue first, 3 over 8, red would be 5 over 7, 1 less, and then blue again would be 2 over 6 because there's 1 less blue and there are 2 like less in total. Now for the last one, oh wait, this would be red, blue, blue. So first red, it's going to be 5 over 8. Then it's going to be 3 over 7. Then it's going to be 2 over 6. Less. And then blue again would be 2 over 6 because there's one less blue and there are two like less in total. Now for the last one, oh wait, this would be red, blue, blue. So first red, it's going to be 5 over 8. Then it's going to be 3 over 7. Then it's going to be 2 over 6. So now 3 times 2 times 5, 30 over 8 times 7 times 6, 336. The numerators are all same, 30, 30, and so are the denominators. So if we add them up, so that's 90 over 336, which simplifies to 30 over 112, which further simplifies to 15 over 56. So that is your simplified probability for picking 2 blue and 1 red pen. Question 6 is a diagram shows a field ABCD. A straight path AC goes across the field. Show that AC equals to 1028 meters correct to the nearest meter. So AC. So first to find AC, we can use the triangle ADC. We have two lengths and the angle between them, which shows that it meets the condition for the cosine rule. So the cosine rule has two conditions. If you're trying to find a missing length, then you need two lengths and the angle between them. And if you're trying to find a missing angle, then you need all three lengths. So we have two lengths and the angle between them, which means we can use the cosine rule. So now we're doing AC square equals to 420 squared plus 830 squared minus 2 times 420 times 830 times cos of 106. So that's going to give us 865,300 for this. Negative 192.174.36. Remember that when you're, squaring them and subtracting and multiplying and all of that, do this part separately and this separately and then subtract the results. Because if you add these up and then subtract 2 times 420 times 830 from this, and without multiplying cos 106 to this, then your answer will be incorrect. This is a very common mistake that students make, that they just directly subtract it without, multiplying cos 106 to it. So solve this part first and then subtract the result from the sum of this part. So 865,300 plus 192.174.36. Then we're going to square root this. 1057474.36. Square root that, and what we get is 1028.335 meters, which rounds up to 1028 meters, correct to the nearest meter. So if you remember your conditions of like cosine rule and sine rule, then these questions are not very difficult to solve. Angle ACB is obtuse. Calculate angle ACB. Okay, so ACB is this one. So we just found this length, which is 1028. So we have to find this. So now if you notice, we have a length and its corresponding angle. A length and we need to find its corresponding angle, which shows that this meets the condition for sine rule now. Now, if you have a complete set of length and angle, then you can easily apply sine rule to find a missing angle or missing length based on the information given. So in this case, we will do 1028 divided by sine of 62 equals to 1150 divided by sine of angle C. So that is going to be 1028 divided by sine 62. 1164.28 times sine of angle C equals to 1150. Sine of angle C is going to be these two being divided by each other. That's 0.9877. So sine inverse of this, that's going to give us 81.00 degrees. So now since they said that angle ACB is obtuse, which means we will have to subtract this angle from 180. So 180 minus 81, 99 degrees. If they hadn't said obtuse, then you could have stopped at 81 degrees. But since it says angle ACB is obtuse, we need to subtract it from 180 to get the obtuse part. Part C is part of the field triangle ACD is sold for $41,500. Calculate the cost of 1 hectare of this part of the field, giving your answer correct to the nearest dollar. So for this, we need to find the area of triangle ACD first. So for the area of a non-right angle triangle, the formula we use is 1/2 AB sine of angle C. So for this formula to be used, we need two lengths and the angle between them, same as the cosine rule. And we have two lengths and the angle between them. So we'll do 1/2 times 420 times 830 times sine of angle 106. So when we plug that in the calculator, what we get is 167,547.91 meter square. So 1 hectare equals to 10,000 meters square. To get the cost of 1 hectare of this part of the field. So let's convert this into hectares first. So 1/10,000 hectares is equal to 1 meter square. So that means we divide this by 10,000. That is 16.75 hectares. We have to calculate the cost of 1 hectare of this part of the field. 16.75 hectares cost $41,500. Then for 1 hectare, we'll do 41,500 divided by 16.75, and that gives us 2477.6. Nearest dollar, so that rounds to 2478. Question 7 says a company makes scientific calculators and graphic calculators. Each day they make X scientific calculators and Y graphic calculators. These inequalities describe the number of scientific and graphic calculators they make each day. Complete these two statements. The company makes fewer than 180 scientific calculators each day, and the company can make a maximum of 240 calculators each day because this is the sum. And this is just for scientific, and this is just for graphic. Then scientific calculators cost $12 to make. Graphic calculators cost $18 to make. Each day, the company spends at least $2,700 making calculators. Show that 2x plus 3y greater than equal to 450. So they're making 12x plus 18y spends at least, so that means greater than 2,700. So if we divide these by 3, we get 4x plus 6y and 900, and we can again divide these by 2, which leaves us with 2x plus 3y greater than equal to 450, which is what they wanted us to show. The region R satisfies these four inequalities. By drawing 4 suitable lines and shading unwanted regions, find and label the region R. First, we draw a line at x equals to 180. Then at 90, then x plus y 240. So for that, if I put x equals to 0, then y would be 240, and if I put y equals to 0, x would be 240. So one is over here and the other is over here. Now 2x plus 3y equals to 450. X is 0, so y would be 450 divided by 3, which is 150. X 0, y 150, and if y is 0, x would be 2x equals to 450, which shows that x equals to 450 divided by 2, and that gives us 225. So 10, 20, 25. Okay, now comes the shading part. X is less than 180, which means we shade the greater than 180 part. Shade the unwanted regions. This part. Then x is less than equal to 90. So less than equal to 90 is going to be, so greater than will be shaded. Because we want unwanted. And also for this, the 180 line is going to be dotted because it's x is less than 180, not less than equal to. So for this, I need to draw a dotted line. Now, x plus y is less than equal to 240. So we shade the greater part. Then 2x plus 3y is greater than equal to 450, which means the less than part. So R is this. This is region R. Then it says scientific calculators are sold for a profit of $10. Graphic calculators are sold for a profit of $30. Calculate the maximum profit made by the company in one day. To find the maximum profit, you need to find the maximum number of calculators we're making in the profitable part over here. So for that, it's 90 and it is 150. Yeah. So for y, it's 90. And for x, it's 150. So now if we go down and remove all of this, y is 90, x is 150. Since scientific calculator is x and graphic is y, so we're going to do 150 times 10 plus 90 times 30 to find the maximum profit. 1500 plus 2700, and that gives us $4,200 as the maximum profit. For the x and y value, you look at the maximum value in the given region, which was at x equals to 150 and y equals to 90. And then you use those values to find the maximum profit using the per calculator profit that they're earning for $10 and $30. Question 8 says f of x equals to 7 minus 3x and g of x equals to x squared minus 16. Find the value of x when g of x is 20. So 20 equals to x squared minus 16. 20 plus 16 equals to x squared. 36 is x squared. Square root both sides, and plus minus 6 is the value of x. And find the inverse of f of x. So you first put the function equal to y. So y equals to 7 minus 3x. Then we swap 3x with y because I want the variable that I want to make the subject, which is x, to be positive. So then we divide both sides by 3, and x equals to 7 minus y over 3. As you can see now, x is the subject of the equation, not y. So last step is to replace x with f inverse x and y with x. So this is our inverse. Very basic steps. First, you replace the function with y. Then you rearrange the equation to make x the subject. And lastly, you replace x with the inverse function notation and then replace the y with x. Then it says find g of x plus 1, giving your answer in its simplest form. So for g of fx, we're substituting f of x into g, which means the domain of g of x now is f of x. So g of f of x is going to be square root of 7 minus 3x now. And the negative 16 comes as it is. As I said, we're replacing the domain of g of x with f of x. That's why instead of writing x squared, I'm writing 7 minus 3x whole square. So now they're saying find plus 1. So g of fx 7 minus 3x whole square minus 16 plus 1. Expand the brackets. That's going to be 49 minus 42x plus 9x squared minus 15. So that's 9x squared minus 42 plus 34. That is your answer in its simplest form. Next over here. On the axis, sketch the graph of y equals to g of x. On your sketch, indicate the values with the graph crossing the axis. So g of x is x squared minus 16. So if we look at the parent function, which of a quadratic function, that is x squared. So this is y equals to x squared. Okay. Now it's y equals to x squared minus 16, which means we're moving 16 units down. So that means our turning point is going to be at 16 now. And the intersection with the y-axis is 16. For the x-axis, it's going to be y equals to x squared minus 16, with y equals to 0. So we have 16 equals to x squared, square root both sides, so we have plus minus 4. So that means if we redraw this, this is what we have. -4, +4. So this is your equation for y equals to x squared minus 16, or g of x equals to x squared minus 16. For the x-intercept, you put y equals to 0. For the y-intercept, you put x equals to 0. So when you put over here, we put y equals to 0. So if I put x equals to 0, that gives us y equals to 0 minus 16, which is -16. So we have 0, -16 as our coordinates, and then we have 4, 0, and we have -4, 0. These are the x-intercepts. And this is our y-intercept. That's your curve. Then it says find the equation of the tangent to the graph of y equals to g of x, where x equals to -3, and give your answer in the form of y equals to mx plus c. So g of x was x squared minus 16. They want the equation of the tangent of the graph when x is -3. So now remember your equation, your gradient of the tangent and gradient of the curve are exactly the same. So to find the gradient of this curve, we will differentiate this. So dy over dx. So in differentiation, your power of the variable comes down, and then you subtract 1 from the power. Derivative of a constant is always 0, so this comes as 0. So we have 2x over here. Now it says that we need to find the equation of the tangent at the point x equals to -3. So that means we substitute x equals to -3 in the equation. So that's going to be 2 times -3 for the dy by dx, and that gives us -6. Now this is your gradient of the tangent. Like I said, the gradient of the tangent and gradient of the curve are exactly the same. Gradient of the curve and normal, they are different now. They're not the same. So we have an x value, we have the gradient now. Now we need the corresponding y value. So for the corresponding y value, we're going to substitute x equals to -3 in g of x. So g of -3, which is -3 squared minus 16, 9 minus 16, and that gives us -7. So the point we have over here is -3 and -7. Now using this point and this gradient, we're going to find the equation. So using the point slope form, y minus y1 equals to m times x minus x1. y1 is -7, m is -6, x1 is -3. So you substitute all of this. Y plus 7 equals to -6x minus 18. Y equals to -6x minus 25. That is your answer. So once again, remember, gradient of a curve is the same as the gradient of the tangent. So if you are able to find the gradient of the curve by differentiating it and by substituting the point at which the tangent is touching the curve, you can find the gradient of the tangent as well. And once you found that, you can find the corresponding y value if they haven't given it by substituting the x value at which the tangent is touching the curve into the function equation. And that gives you the y coordinate for that point. And once you have the point and the slope, you can use the point slope form to find the equation of the tangent. Then it says h of x equals to 3 to the power of x. On the axis, sketch the graph of y equals to h of x. So for this, remember that this is an exponential function firstly, and exponential functions have an y-intercept. Originally, they don't cross the x-axis unless there has been like a transformation in the original function. Then they would cross the x-axis. Otherwise, like they don't. They always lie above it. So if we put x equals to 0, y would be 3 to the power y would be 3 to the power of 0, which is 1, which means the y-intercept is 1. And this is the direction which our curve is going to be. Like, for example, it's 3 to the power of negative x, then it's going to be in the opposite direction. So this one is the graph for y equals to 3 to the power of x. Write down the equation of the asymptote to the graph of y equals to h of x. That is y equals to 0. Like I said, it doesn't cross the x-axis. Question 9 says ABCDEFGH is a solid cuboid. AB is 10, BC is 8, and CG is 17. Work out the volume of the cuboid. So volume of the cuboid is length times width times height. All three have been given. 10 times 8 times 17, that equals to 1,360 centimeter cube. Then work out the total surface area of the cuboid. So for that, we find the area of each face. So for the front and the back, that's 2 times 10 times 17. From the left and right, 2 times 17 times 8. And for the top and bottom, 2 times 10 times 8. All of this gives us an area of 772 centimeters square. Then calculate the angle between GA and the base ABCD. So we'll draw a right angle triangle like this. This is the angle we're trying to find, the angle between GA and the base ABCD. So first, this is like a very common question that comes every single time. You have to first find the value of AC. Now, this is another right angle triangle. So using Pythagoras, we can find AC. So AC would be square root of 10 square plus 8 square, which gives us 12.81 centimeters. Now that we have GC and AC, we have two lengths, we can find the angle using tangent. Tan of angle A equals to 17 over 12.81. 17 is your opposite and AC is your adjacent. So tan inverse of this gives us 53 degrees. That's the angle that the line EG makes with the base. Then it says a straight rod PQ is placed inside the cuboid. One end of the rod P is placed at the midpoint of AB, and the other end of the rod Q rests on GH. HQ is 2, QG equals to 4:1. Calculate the length of the rod PQ. So if P is the midpoint of AB, this is 5, this is also 5. On the end of the rod P is placed at the point. The end of the rod Q rests on GH, where it's 4:1. 1, 4. So this is 10. So HQ would be 4/5 of 10 because these are all the same lengths. This is 10, this is 10. So that's 8 centimeters. And what's it called? QG is 1/5 of 10. So that's 2 centimeters. So now that we know that this is 2, erase this, and this length is 8. So if we connect this line and do this straighten over, this is 17. This is make a right angle over here. You need to find this one over. If I say this is M, let's say. So you need to find PM. So to find PM, if we draw a straight line over here, this is another right angle triangle. So if entire PB is 5 and OG is 2, that means this part over, this is going to be 3. This is 3, this is 2. And this PM is 8 because PM is the same as, sorry, not PM, this length that's connecting this point and M, that's 8. So if you draw a triangle, 8, 3, this is P and this is M. This is what we're trying to find. So we can find this using Pythagoras. 8 squared plus 3 squared equals to PM squared. So PM equals to square root of 64 plus 9. And that gives us 8.54 centimeters. So now using this 8.54 and this 17, we can find PQ. PQ is going to be square root of 17 squared plus 8.54 squared. And that gives us square root of 362, which equals 19.03 centimeters. That is your length of PQ. And question 10 says this rectangle has area 190 centimeters square. Performing and solving an equation show that x equals to 8.5. So 190 would equal to 2x plus 3 being multiplied to x plus 1, which is basically 2x squared plus 2x plus 3x plus 3. And that is 2x squared plus 5x plus 3. Then we bring the 190 to the other side. So it gets subtracted. And that gives us 2x squared plus 5x minus 187. Now we have to solve this quadratic equation. We can use the quadratic formula. X equals to negative b plus minus square root of b squared minus 4ac over 2a. So that's negative 5. If write a, that's 2, b is 5, and c is negative 187. Plus minus square root of 5 squared minus 4 times 2 times negative 187 over 2 times 2. This gives us minus 5 plus minus square root of 1521 over 4. So square root of 1521 is 39. So negative 5 plus minus 39 over 4. Since we need the positive value, so we're going to do negative 5 plus 39 divided by 4, and that gives us 8.5. We don't need the negative value, so there's no point in solving for that. We just do negative 5 plus 39 divided by 4, and that equals to 8.5. And work out the perimeter of the rectangle. If x is 8.5, perimeter is going to be 2x plus 3, 2 times 2x plus 3 plus 2 times x plus 1. Perimeter is in the entire boundary of the shape. So 4x plus 6 plus 2x plus 2, which is 6x plus 8. And now we can substitute the value of x, and that will give us the answer of 59 centimeters. That is the perimeter of the rectangle. Then part B says the diagram shows a sector OAB of a circle with center and a chord AB. The shaded segment has area 30 centimeters square. Show that R equals 3.7 correct to 1 decimal place. So if the shaded segment is 30 centimeters square, let's call this A1 and the entire thing A2. So A1 would be 1 over 2 times R squared times sine of 50. This is a non-right angle triangle. So we use the formula for the area of a non-right angle triangle, 1 over 2 AB sine C. So for this formula to be applicable, we need two lengths and the angle between them. And the two lengths over here is the radius which we're trying to find. This is A1. Now sine 50 has the value of 0.766. So if we divide that by 2, we get 0.383 R square. That is A1. Now A2 would be the area of the sector. Area of the sector. So that's 50 over 360 times pi R square. So 50 divided by 360 times pi, that's 0.436 R square. So that means shaded area is going to be the difference of these two. So 30 equals to area of the sector minus area of the triangle OAB, and that is 0.053 over here. We divide 30 by 0.053, and then we take the square root of that. So that's 566.03 equals to R square. And R is going to be the square root of 566.03, which equals to 3.7 correct to 1 decimal place, which is exactly the same as the measurement given in the question. Calculate the perimeter of the shaded segment. So for the perimeter, we need the arc length and we need this length. So for this length, we're going to use the cosine rule to find AB. And for the arc length, we're going to use the arc length formula. So for AB square equals to R square plus R square minus 2R square cos of 50. R square we found to be 23.7. So 23.7 squared plus 23.7 squared minus 2 times again 23.7 squared cos of 50, and that will give us 401.285. We square root that, and that gives us 20.03 centimeters. That is your AB. Now for the arc length, we're going to do 50 over 360 times 2 pi, and R is 23.7. That gives us 20.68. Centimeters. So the perimeter is going to be the sum of these two, and that is going to give us 40.71 centimeters. That is your perimeter of the shaded segment.